Hello, everybody. Welcome back to another episode of Learn with Dr. G. Good evening. Today, we are going to be talking about UNIX shell and also, I hate this, regex, however you want to say it. It's a regular expression. So I say regex, but then it sounds wonky when I say regex. So who knows? Hard G or soft G? What do y'all think? As always, just a quick reminder of our code of conduct. Basically, our code of conduct is let's be kind to each other. I will be kind to you. You can be kind to me, and we'll learn together. All right. So this is what we're going to be talking about today. This is the UNIX shell learn module. And let me plop this link over here into the comments. There we go. And if you want to follow along, feel free to jump in there. One second. All right. All right. Let me put this here. All right, perfect. So this is the module that we're going to be following along with today. If you'd like to follow along, you can follow along in the browser. There will be a sandbox. I'm actually going to do this using my WSL terminal. But if you want to follow along in the browser, you definitely can do that. If you are new to this series, this is the What You Didn't Learn in School series, and we follow, one sec, let me, there we go. We're following a bunch of different pieces of content around things like Bash and PowerShell, Git, GitHub. So a lot of what we're going to be talking about today, we have seen in the past. You can check out all of those videos at aka.ms/learnwithdrg/wydlis_videos. And if you want to check out all of the Learn modules that we've talked about in all of these videos, without going to each video, you can head over to aka.ms/learnwithdrg/wydlis, what you didn't learn in school. And you can find all of those there. All right. All right. So let's go ahead and get started. Today, we're going to be talking about UNIX. And let's just go ahead and do this. You might have recalled that a shell, like a UNIX shell, this is basically our one way to interface with the computer behind. So we type in commands and the shell can interpret and execute them for us on our computer. Today, we're going to be focusing on some basic commands for UNIX shells that allow us to kind of understand or explore files and data within those files. So we're going to be doing things like some basic file inspection. We're going to be using cat, C-A-T, which allows us to create, append, or display files, as well as concatenate. We're going to be doing some regular expressions for text pattern matching. And we've touched on regular expressions in the past. If you remember the asterisk or star and question mark, things like that. And then we're also going to be doing grep. Again, we touched on grep in the past. I think it was on our Bash module. We touched on it, but we're going to be doing a lot more of that. And then doing some piping and filtering for our data. Perfect. So let me go ahead and open this up. Sorry, there we go. Nope, I don't want GitHub Desktop to open. Okay, there we go. Okay, so I've just got a basic Ubuntu terminal here. This is WSL, and this is the terminal. Yes, we are going to be doing SED or SED. So this is a basic WSL terminal, and WSL is Windows subsystem for Linux, and I have installed Ubuntu, and so that's what I'll be using here today. I'm going to go in and out on our kind of zoom here, because sometimes we'll want to see a lot more than what is displayed on the screen. Okay, so the first thing that we're going to be talking about is some basic file inspections. And so one really useful thing is that this project works, this Learn module has some files, some text files that make it easy for us to engage with this module. So these text files, they're inside of the module. If you head over to the second unit, there's a command here, wget. So this is going to be basically grabbing a file from the internet, or from a file location, in this case on the internet. And if you notice this wget command, it's getting it from raw.github-content.com/microsoft-docs/mslearn-data wrangling shell, blah, 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 blah. If you ever see a URL that starts with the raw.github-content.com, you can actually go check out that repository if it's public. So that repository is here, and I'll throw this in the comments as well. Oops. And so it's Microsoft Docs/mslearn-data-wrangling-shell. You don't want to have the main part because that's just the main branch here. But we can see that we've got these two text files in here, and they're very large. And that's the point, is that when we're doing data wrangling, we want to show examples with a lot of text. So here's one that is also very large, but not quite as large as that other one. So you can see it's got about 703 lines in this file. And so that's useful for us because then we can do some fun projects without having to, automatically generate this information or create it manually or happen to have one on hand. So the first thing that we're going to do is, and I recommend doing this anytime you're trying something out new, is create a folder. So then that way you can more effectively clean up what you've just done. So we're going to make a directory. We've covered mkdir in the past. Make a directory data. This is just making a folder. And then we're going to run this wget command. And there's a few ways that you can do it. One is running wget, where we're going to be putting it inside of the data folder, and then we're grabbing it from here. So we can see that it's doing that. And if we were to ls our data, we can see that it's in there. You could also change directory into that folder and just do a dot instead, but the Learn module has us doing it this way. So for ease of use of copying and pasting, we'll go ahead and do that. So if we change directory into data, let's clear our screen and ls, we can see that we have successfully downloaded these two text files that we also saw up here on GitHub. So they're just right here. All right. So the next thing that we're going to do is just kind of see if we can peek inside these files. I mean, there's a number of ways that you could do this. If you were just in a Unix shell and you didn't have access to other programs, though, I mean, one way that you can do this that I like to engage is using Vim. We covered Vim in the past. It's just like a simple editor here. So I could, open this up like this, and we can see it. I mean, it's very large at the moment. But that opens it up kind of in this new view rather than just having us stay within this shell where we can actually type these commands. So another way that we can do this is by using head, tail, or cat. So head and tail will give us the first few or the last few lines in our file, and cat will kind of display the file, which we'll get to in a bit. So for example, one of the commands that it suggests that we run is tail, where we're going to be running kind of try to get all this on one screen. So tail is the command that we're running. We're doing a flag of -n to tell us the number of lines that we want to be printing out into the terminal. 5 is the option for that flag, or almost like the parameter for that flag. And then the other parameter or option for that command is the file. So we want to get the last 5 lines of nasa-software-api.txt and show them in the terminal. Again, this is where I was saying I'm going to move from zoomed in to zoomed out. So we can see here that running that gives us 5 lines, and it's these last 5 lines here. We can do the same thing with the head. So here's our command right here. Whoa, there it is. So head is our command, -n 5, and then the NASA software API.txt file will give us the first 5 lines of the file. And if we were to run the vim NASA software API text or .txt, we can see those first 5 lines start with ARC, and it looks to be the academic worldwide, open source, general US, general US, general US. And those are the same ones that we see over here. So that's really effective, particularly for folks who might be doing some data science or dealing just with large data files, because you can get a sense for our data files all up. We've seen similar commands in Python when we've done head and tail on data frames, for example. I mentioned that from previous Learn with Dr. G episodes. Okay. So that's great. But one piece of information is kind of missing here, which is kind of where are we in this file? I mean, how large is this file? How many lines of text or data does this file have? So NL, like number of lines, you can think of it, basically will give us the line number and associated with each line of text. So for example, here, if we were to write this command, what we have here is the command NL with the option -s. This is our separator. So whatever comes after it, so this equal sign right here, that's going to be the character that we use to separate the line number from the actual line of data. And then we pass in that same file name right here. So if we ran this, we can see that there are 700 lines. And if we kind of keep scrolling, we can see that each line has been printed out to our terminal and is displayed here. By the way, if you ever are scrolling up in a terminal and then you just want to get all the way back down, you can just push enter and it'll recenter your terminal back down. And we can see down here that that's exactly what it did. So it created it numbered each one of our lines, put in the equal sign separator right there, and then this is the actual line that is our data or text in this case. I'll go ahead and clear this out. As with anything, we're going to have a lot of different options for different commands. So the NL command to give us kind of the line numbers, or as it's reading the lines, giving us what line number it's reading. Also has, in addition to -s, it has -i, which will allow us to change the increment. So for example, if we wanted to rerun this command, but also put -i 10, I don't know why we would want to do this, but basically we're going to get 6,991 lines, because what it's doing is that every line it's going to increment by 10. You know, I actually didn't stop to think about why I might want to do this, but I could imagine, I guess I could imagine it. I could imagine if the line maybe was representing like multiple pieces of data, maybe 5 on each line, then you might want to do it by 5 so that you know how many pieces of data that you have. So -i, that's going to be the command. So this is the command right here. Just to kind of show it off a little bit. So we've got -s for what the separator will be, and then -i for the incrementation, like the increment, right? How much we want to increment by for each line that it's printing out. Okay, we can also change the starting number. So if we wanted to rerun this, but do like -v10, so this is our new command right here. -v is going to change the number that it starts on. So rather than starting at 1, it's going to start at 10. So we would expect previously when we did this, we got 700 lines. This time we're going to get, well, starts at 0, right? So 709. So that is our, goodness. Right there. 709 lines. Okay. We can also do some formatting. So for example, we can run this, but we can do -n for our formatting and do like a left formatting. So we can see the difference here is that it formatted all of our output to the left and then had our separator and then has our line. If we did the same thing, but with RN, we're going to get a right formatting. So you can imagine these as columns. So now it's going to kind of move it over. And then if you did the same thing, but used RZ, which is going to be a right formatting, but with zeros to fill in, then you'll get these kind of, ooh, I just zoomed in on the wrong side. You'll get these zeros over on the side to kind of fill in. And this is perhaps not super useful if you're just printing it out to the terminal, but we're going to get into piping this into other files in just a second. All right, just checking on comments. Awesome. I'm glad that this is useful for you for brushing up on skills. Welcome. Let me check our other, just making sure. Okay, cool. Perfect. Okay, so the next thing that we're going to explore is WC, which is word count. So the very first thing that we'll do, and I can zoom in this time, is just run the command simply. So WC is word count, and then you pass in the file or whatever that you want to be able to read the word count for. And what we get here is the number of lines, the number of words, and the number of characters. So lines are delimited by a new line character or like pushing enter. Words are delimited by a space, and then characters are individual characters. So we can see that there are 703 lines, 8,917 words, and 81,115 characters. You might notice that we have 703 lines here, but when we did the like NL command, it only showed 700. That's because the NL command excludes lines that are blank. So this will not exclude that. It's just looking for that new line character. So if you pushed enter, so that's why we have 703. And actually, if you look back up on our GitHub repo and we look down at this one, when we did this, there were 703 lines in this file. I don't know if we'll easily be able to catch the ones that have nothing on them. Oh, there we go. So here's 254, 245 are blank lines, 230. So there's our 3 blank lines in our file that are not being counted by the NL character or command. Hello, how are you? If you wanted to actually use the NL command and get 703, making sure that you do count lines, even if they are blank, even if they have no data or text on them, you can use this -B option flag with A to say, I want all of them. So if we run this, we can see that now we're getting 703 versus the 700 when we didn't run it with -BA. That's one thing that's very important about I mean, any APIs / commands, and this is kind of like an API for your terminal, right? But anytime you're using any kind of call to a command or a function or whatever it is, whether you're in a terminal or in code, it is very important that you understand what the assumptions are that are being made around that. Remember that humans are the ones who are writing these commands and defining them, and functions and defining them, and they are making decisions typically based on what makes sense. But if I were to think about NL as a command, I would personally assume that it was going to count all lines, and that I would have to have the flag I would have to add the flag to say exclude any blank lines. But in this case, the assumption is, or sorry, the default is that it excludes blank lines, which I guess does make sense if I'm thinking about these files as data, because I typically don't want to include non-data or, just blank lines that isn't data. But that is a decision that the folks who defined NL made. And so it's very, very important that you take a second to test out and read documentation on any commands or functions or whatever you're calling before just kind of going through and making decisions based off of that. All right. So let's explore cat command a little bit together. Mainly, cat is used to display the contents of a file. So we can run cat like this. And sorry, I did that kind of fast. Basically, we're just running cat command, and then you pass in a file, and it just literally shows us the whole file right here inside of our terminal window. Not super helpful if that's, I mean, it can be helpful, especially if you're doing like a very small file. It can be very helpful because then you're not opening up into a new window or into a new kind of view. So it can still be very helpful, but in this case, not super helpful because this is just a very large file full of data. So we'll get to how we're going to use kind of piping and things like that to make cat a little bit more useful. First and foremost, one useful thing is to create files with cat. So again, instead of opening up an editor, or whether it's an editor inside the terminal like Vim, or it's an external editor like VS Code, rather than having to open up another program, one thing that you can do is run, here, let me clear this first and make this a little bit bigger. One thing that you can do is run cat with this caret, and then, for example, file 1. Right? And what this is going to do is it's going to, if file 1, it does not exist, so it's going to create and open up this file, essentially. And so right now, our file is open, and it's ready for us to write in it. So I can write something in it. In this case, it suggested that we write NASA headquarters. Okay. And then what I can do is I can do Control D, and that's going to exit out of the file. We've done something similar to this, like if I were to do Vim, like file3.txt, I'm going to open up in my editor here. I can type I for insert mode, write NASA headquarters, then type escape, :WQ. A lot more steps. Maybe that's not a big deal, and that's totally fine. But the nice thing about cat is if you did just need to write like very simple things, maybe you're just like storing some information, or you just need to make a simple command and you don't want to go through all that hassle, it's a very quick way of editing these files. So now if we typed ls, we can see that we've got file 1, we've got file3.txt that I just made, and we've got those NASA ones. So if I ran cat on file 1 right now, we can see that it prints that out. If I ran cat on file3.txt, it also has that, and that's just kind of showing us what's inside of them. All right. If we ran cat on, let's say, file3.txt, sorry. And then I started typing, I don't know, Microsoft headquarters, and then Control D. And then I ran cat on file 3 to just display it. So this first command with the caret is me opening it to the right on it, and then just displaying it here. We can see that now instead of NASA headquarters, so right here, we did cat on file 3 and it said NASA headquarters. But then here, we did cat on file 3 and it says Microsoft headquarters. And that's because this caret is going to open and overwrite a file. So if the file does not exist yet, it'll create that file and open it for writing. If the file does exist, it'll basically overwrite that file. So if this is what it looks like and you actually wanted to add in a line afterwards, then you can use, this is what we have so far, cat, let's do file 1. You can use 2 carets. And this is going to append whatever you have next to that file. So in this case, maybe we want to write the Goddard Space Flight Center. And Control D. Now if I run cat file 1, we can see that it's got both commands, or sorry, both lines. The original line with NASA headquarters and the new line that we just added to it. All right. I said that cat also works for not only creating and writing and displaying files, but also concatenating them. So you can run cat file 1, and this is going to concatenate the contents of those 2 files and kind of display them. So we can run the same thing. Let's take a look at this really quickly. So cat file 1 has the same file printed twice. And cat file 1 has file 1, which had these 2, and then Microsoft headquarters at the bottom. And that's just displaying it. I mean, if we ran cat file 1 again, it's still just those 2. And if we ran cat file 3 again, it's still just that 1. So running cat with the 2 files next to each other doesn't actually change the files because we didn't use that caret. We didn't say we wanted to append it anywhere. We didn't create any new file. We didn't pipe that output anywhere. Cat with just the file with none of these like carets, that is just going to be displaying the file. Similarly, cat with 2 files is just going to display what the output would be of concatenating those 2 files. Hello, Omar. Okay. So what if we did want to actually save a concatenation of files to a new file? Well, cat file 1 is going to have the output of file 1 and file 1 kind of concatenated together. So we can say we want that to be written to file 2. Now, file 2 has both together. So cat file 1 and file 1, and then we want that to be written to a new file, file 2. And then if we displayed the contents of file 2, we can see that there's file 1 and there's file 1. So those are some basic cat commands. Again, I highly recommend that anytime you're going to use commands for the first time, that you do try them out on things that you're not worried about accidentally overwriting, especially when you're doing things in the terminal, when you're not, or like in like a Unix shell, when you're not going to have the like, do you want to save as a new file, those types of things. In our bash stream, we did talk about certain commands and how you can have a flag that allows you to double check to make sure that's what you want to do. But I am using WSL. Okay. So let's go ahead and clear this out and let's start playing around with regular expressions. So basically, regular expressions are a way of doing text pattern matching. And again, we talked about this a little bit in the past, in past videos. And what's really useful is that they're not just useful for a terminal. They're not just useful for a Unix shell. They are useful in many other contexts as well, which I will show you with Visual Studio Code in just a minute. They're also useful in programming languages. So a lot of programming languages will allow you to use regular expressions. And that's going to be useful if you are doing a lot of like data science, for example, Python, SQL, things like that, languages like that. They actually have regular expressions be used often for pattern matching of your data. There is a very useful regular expressions 101 URL or website that I want to share with you all. So that's this one right here. And it's just regex, however you want to say it, 101.com. And what's fun about this is that it allows you to insert a regular expression and have your test string here and just kind of see if this is, if you kind of have an understanding. So again, finding ways of testing things out before you're doing them for real is always useful. You can do that either with test files in your terminal or you can on your machine, or you can do it in something like this. So that's a very great resource that I highly recommend you check out. But let's play around with this a little bit with our text files that we have here. So first of all, let's go ahead and just open up Visual Studio Code. So if you are doing this in the browser, you still will be able to run this exact same command, and it's going to open up a version of VS Code Editor right there in your browser. But if you're using WSL, this will also open Visual Studio Code right here on your desktop, and it will be running in that WSL. Yes, I should probably update. That's fine. But it'll be running. So this is actually VS Code running on Ubuntu because it's my subsystem for Linux. So this is running code with that file name, just opens up that file. So we can see here's that really big file with 703 lines of data, just like before. This is what we've been using. And oh, I'm glad that this is fun and that you're enjoying it. Okay, so let's play around with some regular expressions here. So we can see that open source is kind of everywhere. So we can use that as one of our first regular expressions. Kind of cheating here, but we'll see. So Control F or Command F if you're on Mac. And sorry, let me zoom in a little bit here. It's not as nice looking, but let's go a little bit out. Okay, Control F, and let's just write open source. Make sure that you have this button right here. Make sure that you have this option checked. So right now it's not. It's like light gray, and if I check it, it's got this kind of blue background. I'm on dark mode, but it's got this kind of blue background, and then it's white instead of gray. This is the regular expression like option for find inside of Visual Studio Code. Open source by itself is not that interesting. I mean, technically it's a regular expression, but we're saying, I just want you to find exactly this text. And it has. You can see that it's highlighting each one. So as I push enter, it can kind of scroll through each one. And you can also see over here on the side that each line that has open source on it, it's kind of highlighted in orange. And then I also have this that kind of tells us when there's a lot of it. So you can use those as indicators for where your code might be. So we can kind of scroll through and be like, oh, yep, not a lot of open source right here, a lot right here, none on this screen, et cetera, et cetera. These are all really great visuals for when you're working inside of Visual Studio Code that doesn't even worry about or doesn't really have to do with regular expressions, but is useful for using Visual Studio Code. Do you know how to make WSL2 run services at startup like MySQL? You know, I'm not positive. I mainly use it. I don't use it to run run services at startup, but I'm positive there's probably some documentation on it. So this, is it this one? This is where I would recommend starting out. It's, let me go ahead and create a banner for this. These are the docs pages for WSL, and they can be really useful for getting started. So I bet from here, you should be able to kind of find where they are. Okay. So the, I just forgot to improve this other one. Okay. So from here, we can start to play around with some other actual kind of regular expressions. So this is a list of software. And as we know, APIs often have versions. And as we know, versions are often written like V1, for example. So we can see that there are 14 V1s in here. But we can see that there are also like a V5 and a V6, et cetera, et cetera. So if you were looking for all of the versions and you wanted to be able to quickly find all of these, one thing that you could do is type in V and then a square bracket and then like 1, 2, 3, 4, and 5. So this will give us all instances. You can see now instead of 14, we have 26. So all instances where it says V1 or V2 or V3 or V4 or V5. We can see as we're scrolling through these that there are a number of them. But as I'm scrolling through these, I now see that there's also a 6, 7, 8, 9. And that's kind of annoying that we didn't include those. And let's say you were trying to do like the whole alphabet or something. It's going to get pretty obnoxious to have to write all these out. So one thing that you can do is do a like 1 through 9. So V1 through 9 will give us all of the versions 1 through 9. So now when we're scrolling through all of these, first of all, we now have 31 finds of something with V1 through 9. And when we come back up here, those 6, 7, 8, and 9 are now up there. This square bracket kind of argument for regular expressions will allow you to choose one of the following list. The list can be 1 through 9. It could also be A through Z. So we don't have versions A through Z, but you could have something like this. In this case, what did we just do? It's not versions in this case. This is just looking for a V followed by any other letter, A through Z. So we can find here now VE, VA, etc. Okay. No problem. Now, what if you didn't know what you were looking for? Like you weren't sure if like it was going to be a certain number at the end, or I don't know. You just didn't know what was going to come after it. So, for example, if we were to run NASA .star. So this is telling us that we want to find any character 0 or more times after NASA. So NASA followed by anything, basically. So when we typed just NASA, we were able to find NASA. But if we wanted to make sure NASA basically wasn't the end of the line, well, this would also include that. So this is basically finding anything, but it's going to find the entire line. So if you notice that when we include the dot asterisk dot star, it highlights the entire line. When we don't include it, it only highlights NASA, because we're looking for an entire phrase, word, whatever, text, an entire bit of text that regular expression matches. And this regular expression is NASA followed by 0 or more of any character. There's also what we call anchors, which is basically being able to either find something that is at the start of a line or at the end of a line. So if we wanted to find NASA, but only if it was at the very end of the line, we would use this ampersand, which there aren't any. There aren't any instances of NASA that are only at the end of the line. And if we wanted to find NASA, but only if they're at the very beginning of the line, we would use this little caret. Again, none at the very beginning of the line. We can find some examples here. So maybe ARC. So ARC only at the beginning of the line is going to find us only these ones, 121 instances. If we got rid of that caret, it's also going to find the ones that are at the middle of the line, so 399 instances. So this would be like any line that is starting with the following. If we go to the end of the lines, we can find something. It looks like everything is pretty much ending in quotes. So that's maybe like any number followed by a quote. So we can do something like 1 through 9, quote, and then, oops, sorry, and it's not ampersand, it's dollar sign. 1 through 9, quote, and dollar sign. So this is our regular expression. We want any number 1 through 9, then a quote, and it has to be at the end of the line. So we have 31 instances, and we can see those instances: 8, quote, end of line; 9, quote, end of line; 4, quote, end of line, etc. Hello, Damon. Yes, I'm having fun. Just here learning a little bit about UNIX and regular expressions. So we're able to do some variation. We're able to find specific things. We're able to find if it's at the beginning of the line or at the end of the line. Another thing that we can do is also have escape characters. And so, for example, let's say that we wanted to look for anything that ended in a period. We can't do that because period is matches any single character, right? So when we said dot star, that was any single character. That's not super useful. So we can't say that we want something to end in a period because this actually says I want it to end in any character. Awesome. Cool. Not super useful. Sorry, rather, this is saying I want it to end in any character. So 700, because there are 3, remember, lines that don't have any characters on them. So this is ending in any character. Not super useful. If you wanted to specifically say I want it to end in a period, then you could use a backslash to escape the next commands. So period stands for any character in a regular expression. If you have escape before the period, then period just stands for period. Similarly, maybe you didn't want it to, like, let's just go ahead and add something here. I'm going to add in a dollar sign right here. And let's say that I wanted it to only find me the lines or like the characters where it ended in dollar sign. Well, that's not what this says because the dollar sign represents the end of a line. So if we've used escape, then we can see that there's only one, and it's this one right here that we just added. So this part right here is the actual character dollar sign. And this dollar sign is the regular expression kind of special character that is end of line. And you would do the same thing with a backslash, because remember, backslash is also a special character in regular expressions to indicate that the following character, we want to represent it as the actual character. So if we had backslash, and this is saying that I only want lines that end in backslash. So that first backslash will be the escape character saying the following character, we want it to be representing itself. That is the backslash character. And then the ampersand is the actual end of line. Kind of confusing, but that's why that regular expression 101 website and just kind of playing around with these is very useful. In the Learn module, there's also this really great cheat sheet that you can check out. So it's on here, I believe. So here at the very bottom, there's this cheat sheet that you can explore, matches the beginning of a line, end of a line, any character, white space, non-white space, any character 0 or more times, any character 1 or more times, sorry, a specific character 0 or more times. No, this is just the non-greedy approach. Don't worry about that right now. 1 or more times with the plus, 1 or more times non-greedy. This is all characters that are vowels. This is any single character not in this list. So that's not X, Y, and Z, but any other character. This is the set of characters A through Z or 0 through 9. Where string extraction is to start and where it is to end. All right. I've only got about 10 minutes left. I don't know how these things go by so quickly. But let's head back into our terminal because now we're going to jump into using grep, which will help us use or show us how to use regular expressions when we're actually here. So what we're going to do is use grep, and the way grep works is it's the command grep followed by any pattern, so that patterns that we were just using, and then a specific file to search. Okay, so this is the way that this command works. So for example, if we wanted to find inside of NASA logs anywhere where there was, let's take a look at this, an escape character followed by a star, so an actual star, then an escape followed by a dot, so an actual dot, then the word novo, then there's an escape followed by a dot, so the actual dot, and then DK. So we're looking for a star, dot, novo, I need to figure out how to get that typing, dot, DK. So that's what we're looking for here. That's going to give us all of these. So here's star.novo dk, star.novo dk. Here's all of those files right there. So if you're looking for something specific inside of the file, so these are all in the actual file. And if we kind of zoom out, whoops, zoom out here, we can see it a little bit better. This is in the actual file, right? And these are just lines from that file. So if we were to open the file, let's say cat, or I'm going to do Vim just to, let's do code. So we'll open it in Visual Studio Code. We can see that a lot of these lines start with that, but not all of them, right? So these are just all of the logs, and these first 29 lines start with that star.novo.dk. All right. We can also do some fun stuff here. Like I want to find NASA in both of these files. Whew. 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 That's a lot. Of course, that's a lot because NASA is the, like we're getting these files from NASA. So they're going to be represented a lot. Okay, CED or SED. Basically, this is our ability to edit files, all from the terminal. So, for example, the first thing that we want to do is run, let's clear this out, SED with a blank string and then NASA software API.txt. This is basically the same as running cat and then software blah, 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 because what we're saying is I just want you to grab everything from this file, okay? Not super like useful in terms of we already have cat, so But another thing that we can do is we can grab this file or this text, which is a URL that ends in index.html. Echo will just reprint it out. So if we were to just run echo in the terminal, it would just reprint it out. So running echo, but then piping the output instead of displaying it here in the terminal, piping it to the SED command, where we are specifically stating that what we want to do is grab index.html and replace it with home. So now it's going to print out that same URL, but where index.html was replaced with home. So the way SED works is basically it's all of the things in between those slashes. Those slashes are separating the text fields. And so what we're doing is we're basically saying that we want to substitute this for this. We could do the same thing with a file. We can say, I want to substitute NASA. Anytime you see NASA, I want to substitute it for National Aerospace Agency from this file right here. If we were to run that, then now every time where was going to say NASA, which I'm sure we'll be able to find one fairly quickly, it'll say National Aerospace Agency instead of NASA. Oops. We can also only show, so that if we noticed up here, it took me a while to find one that had that NASA replaced. That's because it's going to print out that entire file with NASA replaced with National Aerospace Agency. We can also use the -n command of SED, sorry, -n flag of the SED command to say, yes, we still want to do that, but we only want to show the ones that have been changed. So here, there's going to be a NASA change on every single line that gets printed out. And again, we can also write this to a new file. Sorry, let me clear this out. We can also write this to a new file instead of just printing it out by running this command. So we're going to say that I only want to grab the lines where we changed NASA to National Aerospace Agency, and I want you to write that to NASA replace.txt. And you're still grabbing it from NASA software.api or -api.txt. And if I were to do cat on NASA replaced, then we can see all those same ones that got printed out before. And the last piece before we head out today is basically, yeah, it can get tricky, but it's definitely sorry, my mind, I started reading another question. It can get tricky, but that's why I like just practicing these. And if you know what you're trying to get to, maybe doing like a practice one without the files, without overwriting things is a good idea. Another question, it's a bit of an advanced question. What if we wanted to find terms that are conceptually but not linguistically similar? Like any word that's a color, would we need a list of all color words to search against that list? When searching unstructured text, this could be somewhat complex search. Yes, that is more advanced for sure. If you're just using basic, like regular expressions, no, it will not allow you to do things that are conceptually the same. That's when you can do things like bring in some AIs that will, like, they already exist. You can just use them, but they would automatically know whether or not they were of certain categories. I don't have a recommendation for a tool right this moment, but it is something that if you're just doing it like inside of a terminal, I doubt that's what you're trying to do. I imagine that you're trying to like have that be a part of a larger question that you're answering. And so I would imagine that you'd probably be bringing in some other bits there. Okay, so let's play around with this a little bit. We've got this command right here. At with the NASA software API, and then we pipe that to NL. Think about maybe for a second what you think is going to happen. Basically, it's just like running NL NASA software API.txt because you're doing cat NASA software API.txt, which is just going to print the whole file out. And then you're piping that output. Instead of printing it out, you're piping it into the NL command, which is just going to apply the line numbers to it. Okay, let's try another one. WC word count -L .txt, star.txt, pipe sort -n. You might not know exactly what this does because we didn't explore all of the like sort command, for example. But basically what it's going to do is it's going to get everything that's currently matches in this directory, anything.txt, where we have 4 files, my file 3.txt, and then the 3 NASA ones. And then we're going to sort it by the line numbers and in ascending order. So file 3.txt only had 1 line number. NASA replaced only 26, 703, and 20,000. If you wanted to show the first line in each of these, sorry, the first line of this, not of each of these, the first line of this output, you would do this. So it's the exact same command, but then we're going to pipe this entire output. We're going to pipe this output to head-n1, which is only going to give us the first one. So file 3. We can also sort them in reverse. So this is going to give us the line numbers with a delimiter of equal sign on this, give us the first 5 lines only, and then sort them in reverse order. So these are the first 5 lines, but in reverse order. So you can see that these are lines, these are lines 1 through 5 in reverse order. So we already did this, put on line numbers and then have a separator for this. We know what that does. We know what head n equals or n5 does. That gives us 5 lines, the top 5 lines, and then sort -r is just going to reverse the sort. All right, last one. Or wait, let me clear. Okay, last one. Kind of a big one. So grep-m10 NASA logs 95.txt, sort in reversed order, then SED-N, NASA National Space Agency. So what we're going to do is we're going to search, but only for the first 10 lines that have NASA in NASA logs. So that is going to grab only the first 10 lines from NASA logs that have the word NASA in them. Then we're going to sort those in reverse order. Then we're going to print those out in, why did the sort in reverse order not work? Did we not assign the line numbers? Is that way? SED, we're running out of time. And then we're going to do this last, running out of time. SED-N, where we're replacing NASA with National Aerospace Agency. The sort didn't sort because I think we forgot to add in the line numbers, which I think I might suggest we do in the Learn module. But so those are some of the main commands. We did grep, SED, word count, line numbers, cat, etc. And I hope that was helpful. As always, if you wouldn't mind filling out, the total has no txt. Sorry, I missed that part. The total. Oh, the total had no txt, right. That's because that was the total number of lines, total number of lines across all of the 4 files. So if you wouldn't mind filling out this survey, it helps us to know if this is the type of content that you want to continue seeing. And there we go. And, oh, sorry, I meant to paste it in the chat here. You just head over to aka.ms/reactor/survey with the code 12885. And it should just take you just a couple of seconds to complete that. And Also, feel free to connect with me on any of the socials. I'm pretty much at Dr. Guthels. And otherwise, I will see you all next time. Thanks so much for hanging out and using Unix with me. Bye, everyone.